Welcome back, children. In the last lecture, we talked about magnetic field in a circular wire which carries current, and we saw how the magnetic lines look like. In continuation with that, let us talk about magnetic field in a current carrying solenoid. Now, what is a solenoid? Let us try to understand the definition, the meaning of a solenoid first. So, what is a solenoid? A solenoid is a coil with many circular closed circular closed turns of insulated copper wire of insulated copper wire looking like a cylinder, like a cylinder whose length is greater than its diameter, whose length is greater than its diameter is called as a solenoid. Is called as a solenoid. So how to make a solenoid? To make a solenoid is very easy. If you are having a straight wire, अगर आपके पास एक वायर है straight, तो आप उसको क्या करोगे? We just make turns of copper. Now this is converted into, आप इसको लो एक पाइप के ऊपर लपेटते जाओ. If you just wind it around a pipe and remove the pipe, you would get a helical spring-like structure. It looks more or less like a spring this way. Now you have got tons of copper wire here, and if you connect this to a cell or a battery, then this would also produce magnetic field lines. Now this is a solenoid. So how to draw the magnetic lines in a solenoid? In a solenoid, the magnetic lines in a solenoid looks similar looks similar to that of a bar magnet. You have already seen how the magnetic lines look like in a bar magnet. So exactly the same way, here also the magnetic lines look similar to that of a bar magnet. Now if you look at this solenoid, current is moving through the solenoid. This is the direction of current. How to draw the magnetic lines? Let us see. First let me erase these things, then we will draw the magnetic lines here. We will draw the magnetic lines by seeing the direction of current. Now how do the magnetic lines look like? They look like a bar magnet. The bar magnet का आपको याद होगा, it's something like this. It goes, they are they are closed loops this way. I need to draw it again. These are the magnetic lines. exactly looking like a bar magnet, something like this way. Make sure that the magnetic lines, they are not intersecting with each other. So something like this. Okay. So the magnetic lines look like exactly like a bar magnet. Now the question is, which side of this solenoid would be north and which side would be south? अब इसमें बड़ा इजी सा एक तरीका है हाउ टू फाइंड आउट द नॉर्थ एंड साउथ डायरेक्शन. लुक एट द साइड थ्रू विच द करंट इज एंटरिंग द कॉइल. अगर आप इस कॉइल में देखोगे तो हमारा कॉइल जो है वो ऐसा है. इट इज समथिंग लाइक दिस. तो यहां से करंट जा रहा है. आई एम मार्किंग द डायरेक्शन ऑफ करंट. तो करंट जाएगा ऐसे, फिर इस तरह से होते हुए जाएगा. द करंट इज एंटरिंग इनटू द कॉइल दिस वे. So try to visualize from this side through which the from the side the current is entering. यहाँ से current, यहाँ पे देखो इसको. If you look from this end, if you see this current is moving in a clockwise direction here. तो यहाँ पे if I mark this as point P and this is point Q, from point P, from the P end, from end P, from P end, what is the direction of current? The direction of current is clockwise in the loop. This is the direction of current. So if the direction of current is clockwise, how to show the north and south pole? Current is clockwise. So if I use the rule, if the current is clockwise, मतलब current अगर ऐसे enter करता है, clockwise हो गया ये, this would become the south of the solenoid. So this would be south. Clockwise current होने से clockwise current तो ये साउथ पोल होगा. But if it is anti-clockwise current, this is the anti-clockwise, this would always create a north pole. So this would be anti-clockwise current. Anti-clockwise current and anti-clockwise current leads to the formation of a north pole. Now come to the diagram again. Now from point P, if I see from point P, the current in the loop is clockwise. So the side P of this solenoid, this becomes the south pole of the solenoid, and this would be the north pole of the solenoid. Now once you know the south and the north, then what to do? We have to mark the direction of the magnetic lines, like the bar magnet. Lines of forces, they move from the north to south. So this would be the direction of the magnetic lines. Okay, from north to south. Okay, so this is the direction of magnetic lines of forces. Now please look at the inner part of the solenoid. If you look at the inner part of the solenoid, the magnetic lines are nearly straight and parallel. Okay, so we can write a statement. In the inner part of the solenoid, in the inner part of the solenoid, sorry, in the inner part of the solenoid, the magnetic lines are straight and parallel. Therefore, magnetic field inside a solenoid inside a solenoid is uniform. Sometimes the question comes in the exam. Show with the help of a diagram that a solenoid produces a uniform magnetic line inside. तो ये हमारा solenoid है. इस solenoid में मैग्नेटिक लाइंस कैसे है, अंदर से स्ट्रेट और पैरेलल, लगभग स्ट्रेट पैरेलल इस तरह से. This is the way the magnetic lines they move inside a solenoid. Something like this. Okay, this would be something similar to this. Okay, so inside it is straight and parallel. So this is about solenoid. Now let us talk about factors. The first factor is obvious, current. If you increase the current, magnetic field strength would increase. More is the current, more is the current, more would be more stronger. More we if we write more is the current, stronger would be the magnetic field. Stronger would be the magnetic field. What about the second factor? You can see that solenoid is made of many turns of copper wire. So the second factor would be the number of turns. Number of turns. So increase the number of turns. Increase in the number of turns. Increase in the number of turns would result in a stronger magnetic field. In a stronger magnetic field. Now, how to increase the magnetic field strength further? Now, the third is important. If you insert a soft iron core, inserting a soft iron core would increase the magnetic field strength, increase the magnetic field strength. मतलब जो वायर है, वायर को एक सॉफ्ट आयरन कोर के ऊपर लपेट दो. जैसे ये हमारा आयरन कोर, लेट अस से दिस इज द आयरन कोर. आप इसके ऊपर वायर को लपेटते जाओ. जैसे ये दिस इज द कॉपर वायर, इसको लपेटा, फिर ये आया, फिर you are just winding the wire above the iron core. So what is happening? This is the iron core. If you wind this wire on this iron core, this would result in a stronger magnetic field. Now what will it happen now? Once you wind the wire over a soft iron core, magnetic field strength will increase, and this will convert into an electromagnet. So solenoids are used to make electromagnets. You take an iron bar, soft iron bar, wind copper wire, pass current, and this would result in the formation of an electromagnet. Now the question sometimes children ask if sir why is soft iron core? Soft iron core एक ऐसा मटेरियल है जिसमें मैग्नेटिक फील्ड तब तक रहता है जब तक करंट रहता है. सॉफ्ट आयरन कोर का काम क्या है? It produces magnetic field only for the time current is passed. Once the current is switched off, the magnetic field completely disappears, अगर हम आयरन कोर की जगह कोई और मटेरियल लेते, जैसे एल्यूमिनियम यूज करते हैं या कॉपर यूज करते हैं, इफ यू यूज एनी अदर मटेरियल other than soft iron, that would result in the formation of a permanent magnet. उसमें पूरा का पूरा मैग्नेटिक फील्ड खत्म नहीं होता, कुछ रेसिडुअल मैग्नेटिक फील्ड उसमें रह जाता है. So that is not advisable. If you are making an electromagnet, you need a magnet only for the time being current is passed. use a Use an iron core. If you want to make a permanent magnet, you can make any other core material like aluminium or copper. Okay, so this is all about solenoid and an electromagnet. Thank you very much.